Okay, students, today we are going to discuss about Modi's method, okay, in solving transportation problem. In the previous video, I was discussing about how to solve a transportation problem like this by what is called LCM method or NWCR method or Wojcicki approximation method. Those will give us only the basic solution for us. That will not give us the optimum solution for us. But this method called the Modi's method definitely will give a optimum solution for us. Okay, so today we are going to discuss this particular problem, and we are going to solve by Modi's method. Now, let us take this particular problem. Okay, right. So now this is what the problem given to us. There are three resource centers or production centers A, B, C, and there are four destinations W, X, Y, Z. And in the A resource, 14 items available. In the B resource, 16 items available. In the C source, 5 items available. Okay, so total availability are 35 items. In the first destination, 6 items are needed. In the second, 10, third, Y, 15, and Z, 4. So total comes 35. So therefore, the problem given is a balanced transportation problem. It is a balanced transportation problem. Right now, let us start this problem by using Modi's method. Okay. So in another video, I was discussing about the algorithm for solving Modi's method. Algorithm for solving Modi's method. Okay. Um, so according to that particular algorithm, that we are going to solve this particular problem. Okay. Right now, first, according to the Modi's method, first we have to solve the problem by any one of the initial basic solution methods, such as NWCR or least cost method or Wojcicki approximation method. So here I am using northwest corner rule. I am using here to get initial basic solution for our problem. Right. So this is what the problem given to us. Okay. There are three resources and four destinations as given in the problem, as we have just seen here. Okay. Right. Now look at that here. By northwest corner rule, our first option for the assignment goes to this particular cell. This is the first northwest corner cell, so we have to assign first to this particular cell. I mean, how much we can transport from this particular production center to these destinations. Okay, that's what first northwest corner cell. So here the availability is 14 and demand is 6. The availability is 14 and demand in this particular destination is 6 items. So the minimum among that is 6. So 14 available, give 6 to the first destination. So the first destination's need is satisfied. Okay, first destination need is satisfied. That's what we have to understand. So remaining how much would be there? 8 items still available from the first production center or resource A, by name A. Okay, right. So this is satisfied. Now remaining cells are this one. Am I correct? So in the remaining cells or leftover cells, this is the next northwest corner cell. Therefore, we have to assign for this the number of items to go from here to here. Okay, right. Now the remaining item here is 8. So the availability are 8 items from the first production center, and the demand here is 10. So demand are here, 10 items are in demand, so 8 items available from the first resource. So give 8 items from here to here, right? So remainder how much is needed? Still 2 items are needed in the second destinations. Okay, so this capacity, I mean the available capacity from the first production center or resource is over. So this is over, this is met. Now remainder cells are these one, am I correct? These are the remaining cells or leftover cells. So among these leftover cells, this is the northwest corner cell. This is the northwest corner cell. So this we have to assign now. Now the total availability are 16 items available or 16 products available here, but only uh, two required in the second destination center. Okay, two required from the second destination center. So from this 16, we can allow to go 2 products to the second destination. Okay, and thus um, the destination is satisfied, the second destination is satisfied. Okay, and here out of 16, 14 items only remains, because 2 items we have given to the second destinations. So now what take place? This is satisfied, and this is satisfied, this is satisfied, this is over. So remaining cells are these 4 cells are left out. So among these 4 cells, which is the northwest corner cell, this is the northwest corner cell. Okay, so this is what we have to assign now. We have to assign, assignment should go here. Okay, so the total availability are 14 products available from the second production center, and the demand in this third destination are 15. Demand is 15, but 14 items or products only available from the second production center. So what can we do? We cannot provide with 15 products here, so 14 we can give, because 14 products available here. So let the 14 products can be given to these particular destinations, and the remaining one more still demand the third destination. But what take place? The second production center, the availability is over. Availability is over in the second production center. Okay, so remaining cells are what? These are the remaining cells. Am I correct? These are the remaining cells. These two are remaining cells. So among these remaining cells, this is the northwest corner cell. Northwest corner cell. So okay, from here, how many products available? 5 products are available from the last production center, and only one demand is still we have to fill up here. So give from 5, give 1 products here to this particular destination, and the remaining 4 products still balance in the last production center. Okay, right. So now this one is satisfied with this, therefore the third destination is also satisfied. Okay, so only leftover cell is this. Now how can we assign for this particular cell? 4 products still available and 4 items or products are needed in the last destination. Okay, so what can we do? Just interchange, give this 4 to this destination, and thereby the availability in the last production center is over, and the destination requirement is satisfied, is met. Okay, right. So this is a way we can assign how much product should go from appropriate production centers to the destinations. Okay, so see here, six products should go from here to here, eight products should go from here to here, two products should go from here to here, 14 products should go from here to here, and one product should go from here to here, and four products should go from here to here. Okay, this is by northwest corner rule. So now what is a solution set by northwest corner rule here? So x11 is equal to 6, x12 this one, x12 is equal to 8, x22 equals 2, x22 equals 2, x23 equals 14, x23 equals 14, x33 equals 1, x33 equals 1, and last x34 is equal to 4. Okay, so this is the way we can make them to go, we can assign them to go. Okay, right, by northwest corner rule. Now what about the total cost? If we do so, what would be the total cost? What would be the total transportation cost? Okay, so for 6 items are transported from here to here at the cost of 6 rupees per one products. Therefore multiply this and this will give you total transportation cost from here to here. Okay, the next one is multiply this and this, that will give you the total cost to transport items from here to here. That is 48 into 4 plus multiply this and this. Okay, and that will give you the total transportation cost from here to here for 2 items at the rate of 9 rupees per products, and then multiply this and this, that will give you the total transportation cost from here to there, and this will give you transportation cost for one item at the rate of 6 rupees per item from here to here. Last one, 4 into 2, gives you the total transportation cost from here to there. If you multiply and add, at last what we are getting is that 128 rupees. So total transportation cost is 128. Okay, that's what we are getting here. But as I already told you that this will not give us the optimum cost for us. Optimum means minimum among minimum, because we are giving importance for only northwest corner cell, northwest corner cell, northwest corner cell, like that. Okay, that we cannot guarantee for a optimum solution for our problem. So we are going for Modi's method. Okay, so let us go to the Modi's method. Okay, so if we go to the Modi's method, according to the Modi's method, the first step is that to find out the fixed cost for all the basic cells. Here, what are the basic cells? The basic cells are the cells which are assigned cells. Assigned cells are called basic cells. Here, this is a basic cell. This is a basic cell because the number is assigned from where to go, from where to go. Here the number is assigned. Here the number is assigned. Here the number is assigned. Here number is assigned. This is a basic cell. This is another basic cell. Third basic cell. Fourth basic cell. Fifth basic cell. Sixth basic cells. Okay. So all these are basic cells. For these basic cells, we have to find out the fixed cost by using this particular formula. By using this particular formula, we have to find the fixed cost. Cij equals ui plus vj for the basic cell. So here it is C11. C11 equals, according to this formula, U1 plus V1. But how much the cost there? The transportation cost per item is 6 rupees. That's 6 rupees we got right. The next one is C12. That is this particular cell. According to that particular formula, C12 equals U1 plus V2 equals here the transportation cost per item equals 4. Therefore we will get 4 here. Okay, Right. Similarly, C22. So C22 is equal to U2 plus V2 equals this 9. C23. This is C23. Okay. By the formula, C23 is equal to U2 plus V3 equals how much the transportation cost? 2 rupees. Okay. The next cell is what here? Second row, third column, C33. And that C33 is equal to U3 plus V3. 6 rupees is the transportation cost. Okay. The last cell is this. That is basic cell is here. That is C34 equals U3 plus V4 equals the cost, transportation cost is rupees 2 here. Okay, so by using this Cij equals Ui plus Vj, we can calculate the fixed cost for the basic cells. That's very important. Next step is that we have to find the values of Ui's and Vj's here. Okay, we don't know exactly what is a U1, V1, U2, V2, U2, V3, V4. These we don't know. So what we do there, first we are initiating with U1 is equal to 0. Suppose the initial value we are taking like this, it is possible to find out all the other values U2, U3, V1, V2, V3, V4. Everything is possible from this particular formula. Okay, take for example U1 is equal to 0. If U1 is equal to 0, V1 is equal to 6. So that V1 is equal to 6. If U1 is equal to 0 here, then V2 is equal to 4. That is what V2 is equal to 4. Okay, now U2, V2, we have found out what is V2. V2 is 4. So V2 is 4 here. Now what is U2? U2 is equal to V2 equals 9. U2 plus 4 is equal to 9. Therefore, what is U2? U2 is equal to 5. That is, you are bringing this number this side. 9 minus 4, it will be 5. So U2 is equal to 5. U2 is equal to 5. Okay. Now to find out what is V3, U2 we know well. U2 value is 5. Therefore, you bring this that side, you will get V3 is equal to 2 minus 5 is equal to minus 3. That's what we have here. V3 is equal to minus 3. That's what we have here. So similarly, U3, now we have to find what is U3. Okay, right. V3 value we had just now. V3 value is what? Minus 3. Therefore, what is U3? You bring that this side, minus 3, 9 will come there. Therefore, U3 is equal to 9. Okay. So if you put U3 is equal to 9, what is V4? You bring that side, 9, that side, 2 minus 9 minus 7. V4 is equal to minus 7. So this way we can calculate all VI's, UI's and VJ's. UI's and VJ's. Why we find out this? To calculate net to values, these values are needed for us. That's why by setting U1 is equal to 0, by setting U1 is equal to 0, by setting U1 is equal to 0, we are finding out other values. Okay, U2, U3, V1, V2, V3 and V4. Okay. Now, by Modi's method, the next step is that we have to calculate net values for non-basic cells. Net values for non-basic cells we have to calculate here. Net values for non-basic cells. Okay. So in this particular, the table is needed for us here. Okay, little, yeah, little, yeah, that's enough. Now, net values for non-basic cells. In this particular assignment table that we have just before by Northwest Corner rule, non-basic cells are the cells which have no assignment. Okay, so in this particular case, this cell don't have assignment. Am I correct? See, there's no assignment. No products are allowed to go from here to here. No products are allowed to go from here to here. So this is non-basic cell. That's what 1 3 is non-basic cell. 1 4 is non-basic cell. 2 1 is non-basic cell, and 2 4 is non-basic cell, and then 3 1 is non-basic cell, and last one 3 2 is non-basic cells. Therefore, this is one non-basic cell, this is a 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 non-basic cell, and this is also a non-basic cell. For this non-basic cell, okay, we have to find the net values by using the formula inside the bracket I comma j equals ui plus vj minus eij. By using this particular formula, ij equals ui plus vj minus eij, we have to find the net values for non-basic cells. Okay, here what are the non-basic cells? Here 1 3. Therefore 1 3. By this formula 1 comma 3 equals u1 plus v3, u1 plus v3, not 2 here, v3 minus c13. Okay, that is what the formula says. Am I correct? In the place of I, you substitute I. In the place of j, you substitute the value of j here in this particular formula. You will get 1 comma 3 equals u1 plus v3 minus c13. Now, what is the value of u1? That value of u1 is 0. What is value of v3? Value of v3 is minus 3. Look at this here. So substitute this value here, minus C13. C13 means this cost, transportation cost. This is C13, okay? This is C13. So that is what 1. So 0 minus 3 minus 1 equals minus 4. Therefore, net values for this particular cell, non-basic cell, is minus 4. Next non-basic cell is this, and that non-basic cell 1 comma 4. By using this formula 1 comma 4 equals u1 plus v4, u1 plus v4 minus c14, u1 plus v4 minus c14. You substitute these values of u1 and v4. u1 is 0, minus v4 is minus 7, minus this c14 is this transportation cost in this particular cell. So c14 is equal to 5. So by the formula minus 5. So total comes minus 12. Similarly 2 comma 1, 2 comma 1, this is next non-basic cell. In that non-basic cell, use this particular formula. You will get u2 plus v1 minus c21. From this calculation, u2 is equal to 5, v1 is equal to 6 minus, this is what I told just before, the transportation cost here, 8. So what we see here, 11 minus 8 equals 3. Similarly, we can find 2 4. 2 4 means what? This cell, 2 4. Apply the formula here, u2 plus v4 minus c24. The simplification will give you this. Similarly 3 comma 1, your answer is 11, and then 3 comma 2, your answer is 10. Okay, so these are the values, net values for non-basic cells, net values for non-basic cells. Okay, net values for non-basic cells. But what the Modish method says, all these net values, yeah, all these net values must be 0 or negative. Then we say that optimum is reached. Okay, all values here, net values for the non-basic cells, 1 comma 3 minus 4 comes, 1 comma 4 minus 12, okay, 2 comma 3 plus comes, here minus comes, here 11 comes, here 10 comes. If all values are 0 or negative, then optimum is reached. That's what the Moody's method criteria for reaching an optimum. But here we see that some positive net values also existing here. 3 is a positive net value, 11 is the positive net value, and 10 is the positive net values. So there should not a positive net value here. If there exists a positive net values, which implies the optimum is not reached. So here optimum is not reached. Okay, so if optimum is reached, then this will give you the complete solution set for you, and this will give you the transportation cost for this particular method. But since here we have some positive entries in the net values, then optimum is not reached. Optimum is not reached. Okay, so if optimum is not reached, what we have to do next? That's what we have to understand. So optimum is not reached, then the Moody's method says that optimum is not reached. Then Moody's method says that, see, here the left hand side numbers that we are writing are the basic cells. Let me get basic value 6, 8, 14, here 1, here 4. All these are basic values. At right hand side at the top, those are net values. We are writing net values on the left hand side top. Right hand side top. In the left hand side top, the basic values. 6 is a basic values, so because this is a basic cell. 8 is a basic value, it is a basic cell. Okay, and this is also a basic cell. This is also a basic cell, and this is also a basic cell. This is also a basic cell. Non-basic cells are this, 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 then this, then this, this, or basic cells or non-basic cells. You just go see in this particular picture, you will understand that this is a non-basic cell, 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 non-basic cell, non-basic cell. Okay, so that's what the non-basic cell places. We are writing the net values we have calculated just before here. Okay, so non-basic cells, here one non-basic, here one non-basic, and here one non-basic, here one non-basic, here one non-basic, and here one non-basic. Okay, the Moody's method says that next step, that starting from the maximum positive value, that's very important. Starting from the maximum positive net value, maximum positive net value. Here the net value is -4, here -12, here -9, and here 11, here 10. So positive, maximum positive net value is here. Okay, so if we have to start making loop from this cell, from this cell, what cell? The maximum positive net value cell. We have to start. After starting, we go straight. We should not go like this. We have to go straight this way or this way. Okay, I'm going like this. Then the corner points must be a basic cell. Okay, the corner point must be a basic cell. Then I am coming like this. I cannot go further because there are no basic cells here. No basic cell, no basic cell. But here only basic cell. So I have to take next corner. Then I have to turn. Okay, I cannot go further because no basic cells here. Here only basic cell. I have to stop here. Then again I'm coming over here. I cannot go further here. There's no basic cell. Here only basic cell. I have to turn back because this is a basic cell. Then where I started, there I have to end. Okay, so this is a way we can draw a loop. There is a rule for drawing a loop. Okay, the loop should go on a straight line only. It may go row wise, it may go column wise, and the corner points must be a basic cells, and it can go in the clockwise direction or anti-clockwise direction. Okay, so those are some of the rules drawing the loop. Okay, right. So according to that particular rule, I am drawing this particular loop. That is the step number 5. And now comes step number 6. According to Mordy's method, step number 6 says that we have to assign theta and minus theta for corner cells of the loop. We have to start theta minus theta, theta minus theta alternatively to the corner points. But where to start? Where to start? We have to start at the maximum positive net values. At maximum positive net value, we have to start assigning theta. For corner points, alternative. Theta, next corner point, minus theta, next corner point, theta, next corner point, minus theta, next corner point, theta, next corner point, minus theta, then theta. Okay, so starting from the maximum positive net values, we have to assign theta minus theta plus theta minus theta plus theta minus theta and then plus theta. We have to assign theta like that. That's what step number 6. Okay, right. Now what is the step number 7? In the step number 7, we have to give the value of theta as the minimum of assigned values in minus theta assigned cells. Okay, that is minimum among assigned values in minus theta assigned cells. In this particular box, you see there, which are the minus theta assigned places or cells. This is a minus theta assigned cell. This is a minus theta assigned cell. This is a minus theta assigned cell. Am I correct? So this is a minus theta assigned cell, basic cell. This is a minus theta assigned basic cell. This is a minus theta assigned basic cell. What are the basic values? Basic values are 6, 2, 1. 6, 2, 1. Among them, which is the minimum? That's what we have to give to theta. Okay, so theta value is equal to minimum among assigned values in minus theta assigned cells. That's very important. So minus theta assigned places are this one, this one, this one. Okay, those assigned values are what? 6, 2, 1. 6, 2, 1. Among these, which is the minimum? 1 is the minimum. That is the value we have to give to theta. We have to give to theta. Okay. So very seriously, you have to identify this. Very, very important. Okay. Right. We have given the value for theta. Okay. Now, what is the next step? The next step is that step number 8. We have to rearrange the values. We have to rearrange the basic values on the basis of theta value we have given just before. Just before, what is the value of theta? We have given theta is equal to 1. Okay. Right. So what we have to do is that theta is equal to 1. So you substitute here theta is equal to 1. Here you substitute the theta is equal to minus 1. You substitute the theta is equal to 1 plus 1. Here you substitute theta is equal to 1. So minus 1. Here you substitute theta is equal to 1. Here you substitute theta is equal to 1. Okay. Right. So if you substitute like that, here 1 will come here. Basic value is 1. Here 6 minus theta, that is minus 1. 5 will come here. Here 8 plus 1, 9 will come here. Here 2 minus 1, 1 will come here. 14 plus 1, 15 will come here. And 1 minus 1, 0 will come here. Okay. I repeat again. Here the the theta value is 1. That's what we identified. That theta value you have to give here and join with the basic value. Okay, here basic value is 0, the theta is 1, so 1 will come here. Here basic value is 6 minus theta value is 1. 6 minus 1, 5. Here basic value is 8, theta value is 1. 8 plus 1, 9. Here basic value is 2, theta value is 1. 2 minus 1, 1. Here basic value is 14, theta value is 1. So 14 plus 1, 15. Here basic value is 1 minus theta value is 1. 1 minus 1 equals 0 here. Okay. So this is the new assigned value for the given problem. Okay. New assigned value for the given problem. And that's what we have done here. Look at that. Don't see these loops and other things. Only look at this particular box. Now here 6 minus theta 5. 8 plus 1, 9 comes here, and here 0 plus 1, 1 comes here, 1 minus 1, 0 comes here, and 14 plus 1, 15 comes here, and 2 minus 1, 1 comes here. Am I correct? So this is what new assignment for us. Okay, new assignment for us. Definitely this new assignment will give the less transportation cost than the previous method. That's what you have to look into. Okay, this new assignment cost definitely gives a less transportation cost than the previous method. Okay, now look at that. You multiply and find out the transportation cost here. 5 into 6 plus 9 into 4 plus 1 into 9 plus 15 into 2 plus 1 into 4 plus 4 into 2, 117. That is the total transportation cost. Now by this particular assignment of assigning the products from the corresponding production center to the destinations. Okay, but previously by northwest corner cell, what was the value? See, what was the value by northwest corner cell? Now look at this. By northwest corner cell, 128 rupees. Okay, northwest corner rule, the assignment like this to allow to go from here to here, 6 items from first to second, 8 items like that. If you assign like that, the total cost comes 128. But by doing all these things, calculation of fixed cost, net values, when the net values are changing, okay, then if there is a positive number comes, we are assigning theta and then minus theta, and doing all those things afterwards, what we got the transportation cost is 117 rupees only. So this is less than the previous cost. Am I correct? This also a true transportation method. Am I correct? Because the totality of the availability transported to different places according to their need. That's what we have to understand. Okay, right. So now we got a new assignment. Am I correct? So according to this assignment, we have to send 5 items from here to there, and 9 items from here to there, 1 item from here to here, like that we have to. If we do like that, definitely the assignment will give us the cost less than the previous method. The cost is very less than the previous method. Now look at that. All the demand and availability are satisfied here. That also very miracle. Okay, very miraculous that the the availability and the demand is satisfied there. Okay, here total availability is 14. Here total availability is 16. Here total availability is 5. Here the total demand is 5 plus 1 6. Here total demand is 10. Here total demand is 15. Here total demand is 4. That's what we are seeing here. Look at that. Now look at this. Okay, so without loss of generality, we have applied the formula, and that particular new assignment gives us less transportation cost. Am I correct? But still, is this a minimum among minimum? Is this an optimum? Is this an optimum? So for that, again, we have to go for calculating the fixed cost for basic cells. The net values we have to calculate. Okay. Then we have to see the net values. All net values must to be negative or 0. If they are not negative or 0, that's a positive. Then again we have to go for drawing the loop, assigning theta, all those things we have to do again. Okay, so next step that whether this is the final step, I mean whether this is the optimum or not, for that we have to check for net values. Okay, so we have to find the fixed cost for the basic cell here. This is one basic cell, this is another basic cell, and then this is another basic cell, this is another basic cell, this is another basic cell, this is another basic cells. So for all those basic cells, we have to calculate this. Okay, C11 is the basic cell, which equals U1 plus V1 equals 6. C12 is the another basic cell, which equals U1 plus V2. That is equal to 4 here. See here the cost 4. And then C22 is the next transportation. C22, this one. Next fixed cost cell. C22 is equal to U2 plus V2. That equals 9. That is the transportation cost. The next cell is what? C22 or C23. This one. Okay, so 23 is equal to U2 plus V3 equals 2. The next one is this one, C31. U3 plus V1 is equal to 4. 4 is the transportation cost. Then C34 equals U4 plus V4. That equals 2. That's what we see here. So as we did before, give U1 is equal to 0. If U1 is equal to 0, V1 is equal to 6. Look at that. If U1 is equal to 0, V1 is equal to 6. If U1 is equal to 0, V2 is equal to 4. V2 is equal to 4. If V2 is equal to 4, U2 is equal to 5. Because we are bringing that 4 that side, 5 will get. So U2 is equal to 5. Like that, U3 is equal to minus 2, V2 is equal to 4, V3 is equal to minus 3, V4 equals minus 4. So we have found out the values of Ui's and Vj's. Now next step is to calculate the net values. Okay, net values by using this particular formula. We have to find the net values here. Net values for what? For non-basic cells. Okay, now look at that. Here, net values are what? We have to bring down, then only we can see that. Otherwise, we cannot. Yeah. Here, net values are this one, this one, this one, this one, this one. Okay, non-basic cells. Those are non-basic cells. So 1, 3. This is, so by using the formula Ui plus Vj minus Cij, okay, we will get 1, 3 equals U1 plus V3 minus C13. But U1 value from this we have to substitute 0 minus V3 value. V3 value is minus 3, minus 3. C13 is how much? 1. So 1 minus 1. So what we'll get here equals minus 4. Okay. So similarly, next one is what? This is a non-basic cell. Okay. So that's what we have to find out. 1 comma 4 equals u1 plus v4 minus e on 4. Okay. Right. So u1 is what the value here? 0. v4 is what the value there? v4 is minus 4. Okay. Minus 4. v4 to minus 4. Okay. We will get 9 here. Minus 5. Minus 5. So minus 4 will come here. v4 is equal to u3. u3 is 2. So plus 4 only will come here. Okay. It's not a minus 4. It is plus 4. So v4 is equal to plus 4. And therefore we are substituting there. Minus 5 is equal to minus 1. Next one is what? 2, 1. This is non-basic cell. Am I correct? So 2, 1. 2, 1 is equal to u2 plus v1 minus c21. u2 from this 5. v1 from this is 6. And minus c21 is equal to 8. So you simplify, you will get 3. Now next cell is what? 2, 4. Next 2, 4 is the next cell. Okay. 2, 1 is the next cell here. 2, 1. You simplify by substituting the values u2 plus v4 minus c24. You will get 2. Similarly, 3, 2 is equal to u3 plus v2 minus c32. You will get minus 1. Last 3, 3. The formula is u3 plus v3 minus c33. Substitute, you will get minus 11. Now what we have to see here? In the net values, all must be negative or 0. No positive number should come. If positive number comes, then optimum is not reached. If the positive number comes, then optimum is not reached. Here we see that 2 numbers coming as a positive, therefore optimum is not reached here. Okay, 2 numbers are positive. Look at that, the net values. Therefore positive in the net values implies optimum is not reached. Optimum is not reached. So what to do next? Okay, we have to draw the loops from the maximum positive net values. Okay, that is what step number 11. Now look at that. Step number 11 is that we have to look for a positive net values. That's what next step. See, assignment theta for theta and minus theta for corner cells. That is step number 11. Okay, now come to the box here. This is a box. So we are assigning theta minus theta plus theta minus theta. Where to start? From maximum positive net values. In our calculation of net values, look at this. In our calculation of the net values, which is the positive, 3 is the positive, maximum positive. Am I correct? 2 minus 1 minus 11 minus 4 minus 1. So 3 is the maximum negative. 3 is the maximum positive net values. Okay. So in this particular table, from maximum positive net value is this. So we have to start here, and you have to draw the loop. I told you how to make a loop. Am I correct? It has to go this direction or this direction, and you should have the corner points as a basic cells. On the way, you should not have any other basic cells. Okay, so here one basic cell comes, then I am coming here. I cannot go further, no basic cells. Here's a basic cell, so I can come down and cannot go here. I cannot go here because there's no basic cell. Here only basic cell. I cannot go here, a basic cell. If I go here, I cannot come like this and come back to my place. Therefore, I am turning back and joining here. Okay, so this is the way we can draw a loop. We can draw a loop. We can draw a loop. That is a step number 11. Now, what is the step number 12? Now, look at that. This step number 12 is that we can assign theta and minus theta. That's what we have to assign now. Okay, so we draw the loop and we assigned theta starting from the maximum positive net values. Then we have to give the corner points the alternative value theta minus theta plus theta minus theta. Then you join here theta minus theta plus theta minus theta. Then you join here. Okay, right, that is what assignment of theta. Then what is the theta value? Theta value is the minimum among minus theta assigned cells basic values, or basic minimum of the basic values in the minus theta assigned places. Here is minus theta assigned places. Here is another minus theta assigned places. Among these the minimum is 1. Okay, minimum is 1. That is the next step. Now look at that. So among these basic values in the minus theta assigned place is 6, and that is 1. So the least value is 1. So that value we have to give here. That value we have to give here. Theta is equal to 1. Here minus 1. Here plus 1. Here minus 1. Like that we have to assign theta values, or values for theta. Here 1. Here minus 1. Here plus 1. Here minus 1. Like that. After assigning theta, we have to rearrange them. Okay, so here 0 basic value, add this 1. So here 0 plus 1, 1 will come here. Then afterwards here 5 minus 1, you will get 4. Here 9 plus 1, 10 you will have here. Here 1 minus 1, 0 you will have here. So here you will have 0 basic value. Here you will have 1 basic value. Here you will have 4 basic value, and here you will have 10 basic value. Other basic value you have to write as it is. 15, 4, 1, all those things you have to write as it is. Okay, so if you do so, a new assignment will be getting. Okay, so that assignment is what? I'll show it to you that assignment now. And so this is what that assignment. Okay, this is what that assignment just we were discussing about. That assignment is this. A new assignment of the second cycle, we have this assignment. Okay, right. We will expand this so that you will understand well. So this is a new assignment. Okay, so what is a new assignment? uh, from the first production center to the first destination, 4 items should be 4 products should be can be transported, or should be transported, or can be transported. Okay, from here to here 10 items can be transported. From here to here 1 item can be transported. From here to here 15 items can be transported. From here to here 1 items can be transported. From here to here 4 items can be transported. So total comes some 35. So total availability equals total demand. So for this, what is the solution set? Okay, now the solution set is from X11, from first production center to the first destination, 4 items we have to transport. From first production center to the second destination, 10 items will be transported. From second protection center to the first destination, one item should be transported, like that. This is the assignment procedure. So if you assign like that, the total transportation cost comes 114. 114 comes here. Can you remember that in the previous cases? Let us go and show it to you. By northwest corner rule, where is that? By Modi method. Here. By northwest corner rule, we got 128. By northwest corner rule, we got the transportation cost as 130. It's at 128 rupees. Then, after doing all these mathematical calculations, the total cost was 117. It is reduced from 128 to 117. By now, after the third cycle, we have got the total cost as 114 rupees. So 3 rupees less than the previous methods or previous cycle. Okay. Okay. Is this the final solution? Is this is an optimum for us? Is this an optimum for us? Is it an optimal solution for us? So what we have to do is that again we have to find the fixed cost for basic cells and then net values for non-basic cells. And that is we have to calculate again. If all the net values are 0 or negative, then we reached our optimum. That is, we have reached the minimum among minimum transportation cost. If any positive number comes, again we have to go for drawing loops from the maximum positive net values, and then we have to assign theta value, theta minus theta, theta for corner points. Then we have to give the value for theta is equal to minimum of the basic values in the minus theta assigned places, and then we have to rearrange them. All those things we have to take in. So now let us check whether this is the final answer. I mean the minimum among minimum. We'll check up. For this we have to find out the fixed cost. Okay, so here basic cells are this and this. That is C11 U1 plus V1 is equal to 6, and C12 is equal to this one, U1 plus V2 is equal to 4, and this is what C21 U2 plus V1 is equal to 8 transportation cost, and C23 is this, transportation cost is 2 rupees, and C31 is this, is equal to U3 plus V1 equals 4, and C34 is this one, the transportation cost is 2 rupees. Then by setting U1 is equal to 0, we will get V1 is equal to 1, U1 is equal to 0, then V2 is equal to 4. Like that we can get the value of U1, U2, U3, and V1, V2, V3, V4 also we can calculate. Okay, right? Now we are checking the net values. Okay, net values for the non-basic cells. Net values for non-basic cells we have to calculate here. So when I see the net values for non-basic cells, now look at that. These are the non-basic cells. Samikite 1314 is a non-basic cell. Then 22, C22, C24, then C32, C33. All these net values we have to calculate by using this particular formula that we have discussed already. So 13 is U1 plus V3 minus U13. The U1 value is 0, V3 value is 0, minus U13 value is minus 1. Therefore, we get the value here as minus 1. Okay, and not a positive value. Here you have to get minus 1. You get here minus 1. And then here also you'll get minus 1. Second one 1 4, here 1 4. The formula is u1 plus v4 minus c1 4, that equals 0 plus 4 minus 5, this equal to minus 1. The next cell is this 2 2 is equal to u2 plus v2 minus c22, that equals 2 plus 4 minus 9 equals minus 3. 6 minus 9 minus 3. Then 2 4, 2 4 this one, and this one 2 4, I see that minus 1. 3 2, this is 3 2. 3 2 is equal to u3 plus v2 minus c32, that equals minus 2 plus 4 minus 3 is equal to minus 1. And last one is c33, this one u3 plus v3 minus c33, that equals minus 2 plus 0 minus 6 equals minus 8. Okay, right, what you see here, in all these net values, all are negative. All are negative. That implies what? Our optimum is reached. Am I correct? So we must understand that the optimum is reached. Optimum is reached. Optimum is reached. Optimum is reached with this solution set and with this total transportation cost. Okay, so less than this we cannot find out the transportation cost, or we cannot find the transportation cost less than this. Okay, we cannot find the transportation cost less than this. Therefore the Modi's method gives us the best solution for us, because that is the optimum method, we say, because that gives us optimum solution for our situations. Okay, so going back to our problem now, very shortly, this is the problem we have taken. And this is what a very beginning problems at the beginning we had taken. Am I correct? Yeah, this is what the problem, where A, B, C are the production center, W, X, Y, Z are the destinations. Then we have to solve by Modi method, and the availability from this is 14 items or 14 products, here 16 products, here 5 products, total 35 products. Here need 6 products, here the demand 10 products, here 15 products, and here 4 products. Okay, so how to transport them by Modi's method? We saw that so if we transport like this from here to here, 4 products at the cost of 6 rupee, at the cost of 6 rupees per product, and transport from here to here at the cost of 4 rupees per items. You transport from here to here one item at the cost of 8 rupees per item. You transport from here to here 15 products at the cost of 2 rupees per item. You transport one item from here to here at the cost of 4 rupees per one item, and transport 4 items from here to here at the cost of 4 rupees. Then every availability and demand would be met, and our transportation cost would be very very minimum, and that minimum we have calculated as 114 rupees, and this is the assignment procedure. Okay, so with that we come to the end of this particular problem, and this is what we call the Modi's method. Okay, it is an optimal method. So thank you very much for being me for the past 1 hour. Thank you.